All right, so we are on the final part of today's lesson, which is lesson 2.8. If you haven't seen the lesson 2.7 video, I do not recommend that you move on to lesson 2.8 because the concepts used in lesson 2.7 are used even in this lesson. So if you haven't watched it, stop what you're doing, go back and watch it now. But just so you know, we are still working with inequalities, and to be exact, now we're going to be doing absolute values of inequalities, okay? We are starting on page 76, okay? Which is actually, we're going to be starting on example 2 in a moment. There's just a few side notes that I want to add that you should see in your printed notes, okay? These are in your printed notes where they talk about absolute value inequalities. And on lesson 2.7, we talked about what a compound inequality is, right? We used the word and or to see if two lines were going to intersect or overlap, or if they were going to separate using the word or. Well, what if you can't tell, though, if it's going to, what type of compound inequality it's going to be? Well, here are some key tricks and tips that will help you out. Now, this only works for absolute value, so please do not use this rule anywhere else. Only for absolute value. As you know, an absolute value, you should know that at some point your equation is going to, your inequality is going to split off into two inequalities. And because they're splitting off into two inequalities, it's going to have the same rules as a compound inequality, meaning they're going to intersect or overlap, or they're going to unite. Okay? So some key tricks to tell if it's going to be an or an and inequality. Whenever you see a greater than sign, right, you know it's going to be or, because greater sounds like greater, okay? Whenever you see less than or less than symbol, that sounds like less than, and, right? So you know that you're going to be using an and version of a compound inequality. So for example 2, we are using rules for compound inequality, but we are using rules for just solving basic absolute values, okay? And I can already tell you that you should already know the first part because we have done it in a previous lesson, lesson 2.3, that you should know that the first step is to isolate the absolute value, meaning make sure that there's nothing outside of these absolute values. And in this case, there isn't, so step 1 is done. Step 2 is to separate them as two different equations. However, you do need to watch for this part because now it's not an equation anymore, it's an inequality. When I separate it, I write it, the first one, exactly the same. 2x minus 7 is greater than 4. Just don't put an absolute value sign. The next part is 2x minus 7. You now know to put a negative 4. However, whenever we're switching this sign, we also are going to switch the inequality. I repeat, please make sure you switch the inequality, okay? Once you change the sign, you're going to also change the inequality. Now, looking back at the original, it was a greater than sign. Hey, doesn't that sound like greater? So meaning, these two inequalities are represented as an or value. In other words, they're going to split up and unite just on one number line. Okay? So once we have this set up, we know it's an or now. We're going to solve. Okay? We're going to add 7 on both sides. I now have 2x is greater than 11. And then I'm going to divide by 2 on both sides, which I obviously can't. So I'm going to actually just leave it as 11 over 2, okay? And that's okay. You can leave it like that. The good news is we're not graphing here, you guys. We're just getting a solution. So for this next part, I'm going to add 7. I get 2x is less than 3. I divide by 2. And I get x is less than 3 over 2. I have my two solutions. And the good news is because it's an or, we don't really need to combine them in any way. So how does it look when you're trying to combine them? Well, I recommend you write the small one first. This is the correct proper answer. X is less than 3 over 2. Write the word or, and then x is greater than 11 over 2. This is your final answer. We're not graphing it as you see. I'm pretty sure you guys know how to graph it if they were to ask you to graph it, but we're not going to graph it here. That's pretty much how you would do something like example number 2, where there's a greater than sign. Now what I want to emphasize next is example 3, which looks like this. The absolute value of x is less than -3. Okay? So remember how the rule that we had when I had something looking like this, just with an equal sign? Can an absolute value ever equal a negative number? No, it cannot. Okay? So in this case, can a number be even more smaller than a negative, meaning this is even a smaller negative? No. There is no answer here. There's nothing can be a negative answer. You can't have a negative response. Okay? So what does that mean in terms of my answers? I can't write it out like this. Well, it's very plain and simple. Because there's no answer, the proper way of saying it is no solution. That's pretty much it. That's all you need to write is no solution. And that's when you notice if something is less than a negative number, meaning it's more negative, meaning not very possible, okay? But that's just to help you out and just to break it down, just in case if you do come to a problem like that. Now we are going to move on to page 77, okay? And to be more exact, we're going to go to example 4 now, okay? Now we're still going to use the same rules as compound inequalities. We're still going to use the same rules for solving absolute value. And we need to make sure that we emphasize on when we're seeing an or an and, okay? So for example 4, it looks like this. It says the absolute value of -4x plus 9, absolute value, minus 11, is less than 4. Okay? So we need to solve this. But the first rule that you should know before you start separating it into two equations is to make sure that your absolute value equation, or inequality, excuse me, in this case, is by itself. And in this case, it's not, because I do have something outside of it. I have a minus 11. I need to move that over before I separate it off. So I'm going to add 11. I now have -4x plus 9, absolute value, is less than 15. Hey, now I have it by itself. Now I can separate it into two. If you have to draw 2 arrows to make sure you're separating it, right, you can do that. And you write the first one exactly how the inequality looks. -4x plus 9 is less than 15. And for the next one, you need to be careful. You're almost writing it the same, at least what's inside the same. You're changing the less than to a greater than, and you're changing the 15 to a -15. Okay, so Mrs. Elliott, how can we tell if this is going to be an and or an or? Well, go back to the original inequality. This was a less than, right? Less than sounds like less and, meaning you know that these are probably going to overlap or they're going to intersect, okay? Let's take a look. Let's continue solving them out separately. I'm going to subtract 9 on both sides. I get -4x is less than 6. And I continue solving by dividing by -4. And in this case, remember, I'm dividing by a negative, so what happens? The sign is going to switch, okay? If you have to kind of remind yourself every time I divide by a negative, I kind of change this up. If you have to put a slash to remind you, that's perfectly fine. But you have x is greater than or equal to, you have -6/4. I'm actually going to simplify this to make it a lot more easier to read. And when I simplify it, I get x is greater than -3/2. So that's my first part, okay? Now my next part is I'm going to subtract 9 on both sides, okay? I get -4x is greater than, this is supposed to be -24. I continue working it out. Hey, again, I'm dividing by a negative. So that means this is going to change. I get x is less than 6. All right, so now this is the tricky part. How do I know what my setup is going to look like in terms of my final answer? Mrs. Elliott, do I need to actually graph it to see where it intersects? Maybe it intersects between the two numbers. Maybe it just intersects at one of these numbers. So there is a quick way of determining how that works, and I'm going to show you now actually. So I'm going to go back to lesson 2.7 and show you the two ands that we worked on before. So if you notice with example 1 back on page 72, they only intersected in this one section. And if you notice, pay attention specifically to the signs. I'm going to kind of box it in a bit more than usual. Okay? They're both going in the same direction. Okay? When they both go in the same direction, okay, depending on if it's less than, then your smaller value is what's being intersected. If it was greater than, then your bigger value is what's being intersected. But because they're both the same, it's only one section of the number line that's being intersected. Now, when you go back to example 2, though, take a look at the inequalities now. What did I end up with? Right? They're going in the opposite direction. When they go in the opposite direction, that's how you know that they're going to unite in between those numbers, okay? Once again, if those inequalities are going in the opposite direction, even though we know it's an and, we know now that it's going to intersect in between. Let's take a look back at this one. Let's take a look at our inequalities. I'll kind of outline it here so you can see it better. As you can see, are they going in the same direction or opposite direction? In this case, opposite direction, meaning you know that they're going to shade towards each other. You don't have to do this part, but it would look something like this. And it would kind of shade towards each other. Okay? So now, how do we actually write this out, though? We always want to put the smallest number first. In this case, -3/2. We want to follow the direction that the arrow or the inequality is pointing at, which is less than x, which is, now we follow this part next, less than 6. So you see, it's kind of like as if I wrote this over here, and I wrote this, but just backwards, okay? And this is my final answer. Okay, this is how you would write an inequality that's and you can determine how it's going to look like, okay? All right, so we are almost done. We're going to do one more part. We are going to do example 5. I'm going to grab a completely different page now. We're going to do example 5 on that same page, page 77, and this time they tell us to write the absolute value of the inequality. And here, I'll put it actually here for right now. Shows you all this, gives you this graph, and this time they actually want you to write it out. So before they were writing it out for you, now they're not writing it out for you, okay? So they just give you the graph and they want you to say what's going on. The good news is you can already tell that this is an intersection, meaning this is an and, okay? So it's going to look something like this, where I'm going to start off with the smallest number, okay, and in this case, -5, okay? We know that -5 is one of our values, and the other value is 1. And the first step of what you should do is to find the midpoint. This is how you would properly write an inequality. Find the midpoint. How do we find the midpoint? Well, remember, all we need to do is just add the two values and divide by 2. -5 plus 1 is -4. -4 divided by 2 is -2. Perfect. All right. So now the next step is to find the distance from the end point, or from one end point. So one end point, I almost spelled that wrong, from one end point to the midpoint. So I can choose any one of these values. And remember, to find the distance, you get the absolute value of a minus b or b minus a, it doesn't matter. And one of these has to be the endpoint, the other has to be the midpoint. So I'm going to choose the endpoint of -5. I'm going to subtract it with my midpoint. What's my midpoint now? -2, so minus -2. And I'm going to solve this out. Well, this is going to be the same thing as saying a plus. -5 plus 2 is the absolute value of -3. The absolute value of -3 is just 3. Okay? I'm almost done here, okay? Almost done. The last step is how to set up, okay? This is to set up an absolute value. Okay? It's very, very important that you look at this. You always have x minus the number that's subtracting x is your midpoint. You're always going to use a less than symbol. And then whatever number is here is your distance. So it's going to look like so. X minus, my midpoint is -2. Absolute value is less than, what's my distance? 3. And to rewrite this even neater, I'm going to put this over here. My final answer is x plus 2 is less than 3. And that's how you would write properly an absolute value inequality. So if they wanted you to actually write out this, kind of work backwards, in other words. Well, that's pretty much it. We did examples 2 through 5 on page 76 and 77. Make sure that before you jump into the chapter 2 test, right, that you make sure you review everything from chapter 2, as well as make sure you take all the quizzes, do the chapter review from your textbook, that homework assignment, and I think you'll be set. All right, have a good one.